All right, so in assignment number 1, we did exponential growth, and today, assignment number 2, we're going to be doing exponential decay functions. So it's still going to be y equals a times b to the x, but the equations are going to look a little bit different. The functions are going to respond a little bit differently because the situations that we're going to be talking about are a little bit different. So let's just go ahead and take a look at this first example. This is how memory works. Suppose you learn 100 new things on a given day, and as each day goes by, you forget half of what you learned. This is true because you may not remember what you had for lunch 5 days ago. You probably remember yesterday, but maybe you don't because that's one of the things that you forgot. And so of those 100 things, how many things will you remember in 7 days? So let's start with this. On day 0, you learned 100 things. After 1 day, you took those 100 things and you only remembered half of it. So we're going to multiply 100 times a half, which means there were 50 things that you remembered. You started with 100. On the second day, you'd only remember half of those 50 things. We could get that number by doing this. You started with 100 things, and we multiplied it times 1/2 to get 50. Then we're going to multiply by 1/2 again, which means we're going to multiply by 1/2 twice. And that's 25 things that you remember. After 3 days, and again, you started with 100 things. Every day that goes by, you're going to multiply it times 1/2. After 3 days, you would multiply it times 1/2 3 times. Well, that's going to be 12.5 of those things. So if we skip down to after 7 days, we're looking at this function right here, which the beginning amount was 100 items. The growth factor is 0.5, and we're going to raise it to the 7th power. This comes from an equation that looks like this. You started with 100, and the growth factor is 0.5 to the x power. The only difference here is that our x in this case is after 7 days. And so we could take our calculators out and figure out what is 100 times 0.5 to the 7th power. So after 7 days, you wouldn't remember one thing, just 0.78125 things. And so that's not very much. So hopefully you remember more than that after a week that goes by. So anyway, the function here that we're talking about is this one right here. And it's still in y equals a times b to the x form. The growth factor is 1/2 because you're forgetting half of it. That's why it's called exponential decay. The a is still the beginning amount, which is 100. If we were to graph it, it would look something like this. We started with 100 things, and then 50 things, and then 25, and then 12.5. It starts shrinking fast, and then it just kind of levels out. Notice it will never be equal to 0. We could take half of 0.78125, and half of that, and half of that, and half of that. We're going to get closer and closer to 0, but it would never really touch it. We're going to talk more about graphing tomorrow. Let's take a look at a different situation. My dad bought his first brand new car that he ever purchased in 1977. It was a 1977 Chevy Vega. It was also the car that I drove when I was in college, and so it's pretty sweet looking. He bought it brand new in 1977 for $3,400. And they say that the cars depreciate in value by 20% every year. So here's what that means. If we write this equation in our form, which is a times b to the x, the beginning amount of the beginning value of the car was $3,400. But what is the growth factor going to be? Again, if I multiplied it times 1, it would just stay $3,400 forever, and it'd still be worth that today. But it loses 20% of its value every year. So if it loses 20% of its value, it retains 80% of its value every year. So we're going to multiply by 0.80 because that's how much of the value of the car is kept from 1 year to the next, to the x power. Here's our function. And so we want to know, what is it going to be worth today? Well, when I'm recording this video, it is 2017. And so let's go from 1977 to 2017. That is a period of 87, 97, that's a period of 40 years ago. So I'm going to take 3,400 times 0.80 to the 40th power to see how much the value of that car is worth today. And that would be a grand total of 45 cents. Unfortunately, we don't have the car anymore. We had to pay to get it towed to a junkyard because I was sitting in my dad's barn for a while and had 4 flat tires. The seats were all rotted out. Nothing worked. Couldn't start it. But the metal was worth some stuff once we took it to the junkyard. So anyway, that is exponential decay. And again, it's in this form here, but it's not growing in value. It's actually shrinking in value. So let's say that the whale population, that's been something of concern for a lot of people. So we have white whales. And again, I'm making this up. I have no idea what the actual numbers are. But let's suppose that in 2001, there were 120,000 whales. But by 2006, the population was 112,000. So it's reason to be concerned because the population had been decreasing, if that's the case. It's not going to be exponential growth. It's going to be exponential decay because the value or the size of the whale population has been shrinking. And so if that continues, we wanted to predict what the population would be, let's just say in 2016 or whatever the year is when we're watching this video. And so again, it's going to be in this form because populations grow exponentially. It's going to be y equals a times b to the x. And what I'm going to do is plug in, I have 2 points here. My first point is 2001. I'm just going to let it be 1, and I'll just say my x values are years after 2000. So 1 year after 2000, there was 120,000 whales, and 6 years after the year 2000, there was 112,000 whales. And so what I'm going to do is I'm going to start with this point here because I want to start with the x value that is the biggest. And so if I plug in my x and my y values, I will have 112,000 for y. That equals a times b to the 6th power. Then if I plug in my other point, I will have 120,000, and that equals a times b to the 1st power. So here's my system of equations. And just like we did yesterday, I'm going to go ahead and divide. I'm going to start by taking 112,000 divided by 120,000, and that is 0.93 repeating equals the a's are going to cancel. B to the 5th over B to the 6th over B to the 1st is B to the 5th. So then if I take the 5th root of both sides, I'm going to end up with a B value. That's the 5th root of 0.93 repeating of 0.986. So that's my B value. So then I want to figure out what my A value is, and I'm just going to go ahead and use this function here. That is 120,000. That equals A times B, which is 0.986 to the 1st power. And so that's just 0.986. So I would take 120,000 divided by 0.98, and we'll get something for an A value, something really close to 121,680. And I used the full decimal for B. So it's going to look something like this for A. So my final equation is going to look like this. My equation is going to be y equals, let me write it up here, y equals 121,680 times the growth factor, which is 0.986, close to that, to the x power. And so we can use then that equation to predict any year. If I wanted to predict 2016, I would just plug in 16 for x. And then that would give me the value. So then that would give you the value of any point at in 2016. And that would end up being 97,106 whales at that point. And so let's go ahead and continue with this discussion by talking about the difference between exponential growth and decay functions. And so, first of all, what is the difference in their equations? And so the first thing that we want to talk about is what their equations look like. Both of them are in the form y equals a times b to the x. But exponential growth functions have a b value that's bigger than 1. Exponential decay functions have a b value that's less than 1. And that's just simply the difference between what the equations look like. What is the difference in their graphs? Well, both of them start out at a certain point, but if it's exponential growth, it shoots up. If it's exponential decay, it shoots down. Both of them do not go below 0. It's impossible for it to be anything that would be negative unless it starts off something as negative. But that's the difference in what their graphs are going to look like. We're going to talk more about that in our next lesson. And then how do the annual percent of increase or decrease to find the growth factor? If it's a 20% increase, the growth factor, well, that's the b value, would be 1.20 because it's 20% bigger than 100%. If it's a decrease of 20%, then it would be 0.80 because it's 20% less than 100%. And that's the main difference between exponential growth and decay and how we can tell the difference. That's what our homework assignment is going to be about for tonight, and we will do that homework assignment, go over questions that you have tomorrow in class. Good luck, and we will see you then.